A fellow maker recently asked if there was a good way to put a thin film pressure sensor into an enclosure and maybe how I would go about it. So here is how I would go about it. I don't know if it's the right way, but it's my way. Now, the thin film sensors are available in a variety of shapes. These are the really the small ones that you see, and in this case, it's a small circle. It's smaller. It looks like about 8 millimeters in diameter, I would say. And when you press it, it changes the resistance. So since you can change the resistance, this can be put in a voltage divider circuit and then can be read by a microcontroller like the Arduino. Okay, so in this case, he was not using one of these real small ones. He was using a larger square one. So here's what I did for the larger square one. First, I figured I'd have to do a support for it. It's 40 millimeters in XY, and so I created this little 3D model here. This is about 3 millimeters thick, and then there's an inset of about 0.75 millimeters, and the sensor, which has double-face tape on the back of it, you take the tape off and you put it in place. And then there's a space cutout for the leads to come through. So first I did one where I was going to hold it together with screws, and then I thought, well, I really don't need screws in this case. And the next version, I have little pins in here. So this is the support for the sensor, and then the top this is my standard joystick size, which is 60 millimeters XY, a little more than 2 inches, I should say. And it has holes here. They don't go all the way through, but the whole idea is to press fit it into place like that. So what ends up is the sensor gets sandwiched in between these two parts, and these are pressed together. Seemed to work all right, so I went forward and started mounting it, and here is how it looks. So this is one of the square sensors that's 40 millimeters XY, and it is held in place here, sandwiched between these two parts, and the black part is press fit into the lid to hold it in place. And these holes here, which this is clear, so it looks like it goes all the way through, but it doesn't, are tapered. So they're a little bit wider on this side than the other side. So as you squeeze it in, it kind of self-tightens. Now, to do a connection to it, a lot of the recommendations is to use a physical connection. I tried doing a DuPont connector, but DuPont connectors will not work with these connectors that are on the boards. So I just said, screw it, and soldered it. Now, one helpful tip, because they warn you that if you're slow on the soldering, you're going to melt the sensor. So what I do whenever I have any sort of specialty parts that are heat sensitive, I always use inverse or reverse tweezers like these, so they naturally close, and I put them in place over the lead while I'm soldering, and this acts like a heat sink. So as I'm soldering, this part of the circuit, the wires will get hot, but any excess heat will go first into the tweezers and keep the sensor cool. So there's a little helpful hint for this sort of thing. Now, on the other end, because I wanted this just to be a sensor and it's going to go to a microcontroller of unknown wherever, is I am doing a TRS jack. You could just use a TRS jack, a 3-pole jack. I always use 4-pin ones because it's consistent. So on the jack itself, I wired in the voltage divider. So on the pin that I'm going to use for power, it's just the red wire going up to the sensor. Now the green wire coming off the sensor, if you think of it that way, is going to the sensor line, and in between the sensor line and ground I have a 10 kilo ohm resistor. So between this 10 kilo ohm resistor and the thin film pressure sensor, you have a voltage divider, because the Arduino can't read resistances directly. So you have to have it read something that it can read. It can read voltages. So you use a voltage divider, and what it does is it compares the two, the fixed resistance to whatever resistance you're getting in the sensor, and the voltage will change depending on the pressure. As the voltage goes up and down between 0 and 3 volts or 0 and 5 volts on an older board, that's a value that can be read by the microcontroller. So that is how that works. So this combines the whole voltage divider all in one kind of soldering adventure. And it's a little finicky, because you have to solder both the other lead and the lead of the resistor into the same post, but it is possible. It's not too tough, and it ends up being a lot cleaner that way. So in this case, now I would put that in place and route the wires and everything, and then my cases, my enclosures here snap together, so there's no screws, and there you go. So now you have a compact, at least as compact as I can make it with these connectors. If you used just a bare wire connector, you could shrink the height a little bit, but really not by a whole lot, because you have to take into account the leads. So there, now you have a decent surface that to press against. The harder you press, the more the resistance changes, which you can monitor and then have that trigger whatever you're going to do in your microcontroller. Like if you had a game, the harder you press, the more lights light up, is a very common example. So there's my solution to the putting these sensors into an enclosure. This was all done in OpenSCAD, of course, because that's what I use. But I have the STLs and the models available. They're all public domain, so if you're looking for them, I'll be happy to provide them. Thanks for watching.